Hi all, welcome back to Math with Amala. Let's move to grade 10 chapter 1 real numbers part number 5. Here we are continuing with the second question of Euclid's division algorithm exercise problems. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. For that, let's take an a as positive integer and a b as 6, because we have to express this in the division algorithm format, because a is equal to bq plus r is the division algorithm format. So we have to take the b as 6, a as any positive integer. Let's express a is equal to 6q plus r. We have substituted b is equal to 6 in the division algorithm format. Okay, where q greater than or equal to 0 and r can be from 0 till 5. Okay, you can't see that 4 and 5, I believe. So there are 0, 1, 2, 3, 4, 5 as r. Okay, now let's put each value for the r and let's write what will be a. When r equal to 0, a is equal to 6q. When r equal to 1, a is equal to 6q plus 1. When r equal to 2, a is equal to 6q plus 2. When r equal to 3, a equal to 6q plus 3. r equal to 4, a equal to 6q plus 4. r equal to 5. Then a is equal to 6q plus 5. Now we have got different a values for different r values. If the remainder is 0, it is just 6q, a multiple of 6. If the remainder is 1, then a is equal to 6q plus 1. That means that it will be an even number, isn't it? A multiple of 6 means it is always an even number, because 6 can be expressed like 2 into 3, where 2 is an even number. So whatever be the number multiplied with 2, it will give the even number. It makes the even number. So 6q is an even. 6q plus 2 is an even number. 6q plus 4 is an even. Likewise, when we take the plus 1 plus 3 plus 5 numbers, it is an odd case. So we have 3 even cases and at the same time 3 odd cases. Thus we can say that any positive odd integer is of the form 6q plus 1, 6q plus 3, 6q plus 5, where q is some integer. Okay, let's move to third question. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Here we have to find the same number of columns in which these two band and the contingent people will be marching. So we have 616 members in the contingent and also 32 members in the band, army band. Here we have to arrange these particular numbers 616 and 32 in some columns, where we have to find the maximum number of columns in which they can march. So the total number is 616 and band members are 32. Total number in the contingent is 616 and band members are 32. Next, we have to find the HCF of these two numbers, 616 and 32. That is the highest common factor, which includes as the column, maximum number of columns, gives maximum number of columns, okay, in which they can march. So let's take the HCF by our Euclid's division algorithm. We can use the same method in order to find the HCF. Here 616 is greater than 32 by Euclid's division algorithm. Let's give 616 in terms of 32. That is 32 into 19 plus 8, where 8 is not equal to 0. Let's do the division algorithm again. 32 is equal to 8 into 4 plus 0. So you have got the remainder as 0. Then HCF of 616 and 32 is equal to 8. Thus we can conclude that the maximum number of columns in which the people can march is 8. Thank you all for watching the video. Please stay tuned for exercise 1.1 part number 6.